Welcome to Spring LIB.
All right, so a fairly straightforward problem here with just a little algebra to go through. So a pion is moving, has to move distance of 32 meters, and its average lifetime, let's call that delta t naught, so that's the rest frame lifetime, is 2.6 times 10 to the negative 8, or 26 nanoseconds, or 2.6 times 10 to the negative 8 seconds. And so you want to find the velocity, right? How fast it's moving. So velocity is distance over time. The time is not delta t naught because in its own reference frame it will be delta t, which you'll remember from equation 26-1a for time dilation is delta t naught equals delta t naught is the rest frame length, time equals delta t moving frame time times 1 minus squared 1 minus v squared over c squared. Okay, so you plug that into here, and so what you get is v equals d over delta t naught. So delta t is delta t naught over 1 over the square root, so the square root goes up here, times 1 minus v squared over c squared. Okay, so we have to make v the subject because v is what we're after. And so the way to do this is obviously squaring both sides. You square, and you get v squared equals d over delta t naught squared times 1 minus v squared over c squared. Okay, and so you have to do some rearranging here, and this is the algebra I was talking about, but it's not too bad. You bring out this delta t naught over d over delta t naught factor to the other side, so v squared times delta t naught over d squared equals 1 minus v squared over c squared. Right, and so let's move to the next page. You can make v the subject, v squared the subject. You already have a delta t naught over d squared term, and then another bracket there. You'll add a 1 over c squared term. It's coming from here, and that is just equal to 1. Right, and so you can multiply, and so you can multiply by c, both sides by c. And so what that gives you is that v squared will be c squared times 1 over, because there's 1 over here, you just divide both sides by this each factor here, over 1 over 1 plus delta t naught over d times c, because remember you multiplied by c, and that's a square. And so therefore velocity is just c, let's leave c in terms of c, times 1 over 1 plus the delta t naught. Delta t naught is, remember, 2.26 nanoseconds, as we said here, so 2.6 times 10 to the negative 8 seconds times speed of light, which of course is 3 times 10 to the 8 meters per second, right, over the distance, which is 32 meters. Notice that all of these are in SI units, so we are doing good in terms of units. And so what you get out of that, after plugging all of that into a calculator or what have you, feet is 0.9716 times the speed of light. And so yeah, that is effectively it.